Alright, this video is on the mean value theorem. Basically what the mean value theorem in calculus says is this: if you have a function that satisfies the following three conditions, it has to be defined on a closed interval, and it's continuous at every point in that interval, and it's differentiable at every point of the interior of the interval, then there exists some value c in the domain of the function at which the instantaneous rate of change is equal to the average rate of change. Geometrically, you can interpret it this way. If you were to plot the function at the endpoints, so at a, f of a, and at b, f of b, obviously the slope of this line would be the average rate of change, or the slope of the secant line. There's going to be some value c in between a and b, where if you were to take the derivative of the function at that point, or in other words find the slope of the tangent line at that point, it's going to be equal to the slope of the secant line from a to b. So just as an example of something that we can do with this, this is just I guess a mechanical type problem to figure out whether or not you really understand what this is saying. So first of all, does the given function satisfy the hypothesis of the mean value theorem? So let's look at that part first. On this one, we need to check three things. Is it defined in a closed interval? And the answer is yes. Is it continuous on that interval? Well, it's a polynomial. Polynomials are continuous everywhere, so certainly it's continuous on this interval. So we're good there. Finally, is it differentiable? This particular one doesn't have any corners, cusps, vertical tangents, anything like that, so the answer is yes. So it satisfies the hypothesis of the mean value theorem. So that means that there's going to be some value c such that the derivative at c is equal to the average rate of change. So what I've done here is two things. Number one, I've found the derivative and I've replaced the x with a c. And on the right side, I've identified that a is -1, b is 2, and I have plugged those in for b and a, and I'm about to find the average rate of change, and then I'm going to get basically a quadratic in c. Alright, so if you put in 2 for x, you're going to get 6, and if you put in -1 for x, you're going to get -3. So the right side of this equation then ends up being 9/3, which is 3. So now you're solving the equation 3c squared minus 2c plus 1 equals 3, or 3c squared minus 2c minus 2 equals 0. Alright, so now we're solving this quadratic in c, which is 3c squared minus 2c minus 2 equals 0. We're going to need the quadratic formula for this. So if we use the quadratic formula, we're going to get that c is equal to 1 plus or minus root of 7/3. And it turns out that both of those values are in between -1 and 2. And so those are the two values of c where the derivative is equal to the average rate of change. Okay, so hopefully this was somewhat helpful in assisting you with the mean value theorem. In the next video, I will show you a more real-life example of why the mean value theorem is useful.